This lesson is on implicit differentiation. And so first of all, what does implicit mean? Well, we normally work with explicit functions. Explicit functions are like y equals x squared plus 3, or y equals 1 over x, or y equals 2x squared minus 3x. These are explicit functions, and that's what you're used to. Implicit relations don't have to pass the vertical line test. That's why I don't call it a function. But you have worked with some of these before. For example, x squared plus y squared equals 4. That's a circle with a center at 0, 0 and a radius of 2. You've also, if you've had the pre-calc class, done things like ellipses and hyperbolas and things like that. And so here's another example of an implicit relation. And notice the difference here. All of the explicit functions have y equals, and then all the x's are the y's are solved for, all the x's are on one side, so y is determined by x. In the implicit, you have a mixture of x's and y's. Some of them would be basically impossible to get the y by itself, but the x's and y's are all together and mixed up. So that's like the main difference you just need to be able to recognize. So what we're going to be doing are these steps right here. The first thing that we're going to do is we're going to take the derivative of the function, I should probably say relation, and when you do that, you want to think of y as an unknown explicit function, like it stands for one of these things over here. So when we say we're taking the derivative of y, we say that is y prime. It's not 1. You treat x like normal. So if you had 5x, the derivative of 5x would be 5. But the derivative of 5y would be 5y prime, because y is standing for something with x's in it. If you had something like y squared, that would mean you're doing a chain rule. If you had x times y, that would be a product rule. Because again, think of it as if y were x squared plus 3. If this were x squared plus 3 squared, you would be doing a chain rule. If this were x times x squared plus 3, you would be doing a product rule. That's how we're thinking of that. We don't know what y is, but it stands for an explicit function. After we do that derivative, we are going to move all the y primes. This is not y's, this is y primes. I just didn't know exactly how to write that any better. To one side, and you're going to move everything else to the other side of the equals, and then you're going to solve for y prime. This is often going to involve using a GCF and things like that. So let's move on to examples. Our first example, we have 7y to the fourth plus x cubed y plus x. So when I look at this, I notice this x cubed y, that's going to be a product rule. 7x to the fourth is going to be a chain rule. The x we treat normally. When we take this derivative, we do the derivative of everything on both sides of the equals mark. So this first one, again, I'm treating it like a chain rule. So I'm going to do the derivative of the outside, which would be 28y cubed, times the derivative of the inside, which would be y prime, because I don't know exactly what that is, so I call it y prime. So that's a chain rule. The second piece here we said was a product rule, and again, when you think of the derivative of y, you call it y prime. So I'm going to do first times the derivative of the second plus the second times the derivative of the first. And again, x's get treated normally. And then the derivative of x is 1, and the derivative of 4 is 0. Be very careful. The biggest mistake that people make is forgetting about when they have a plain number like this 4, forgetting to take that derivative and say it's 0. And that will make your life a little complicated if you don't do that. So after you've taken that derivative, the next step is to get the y primes on one side of the equals mark and everything else on the other. Well, both of the things that have y prime, this first thing and the second thing, are already on the same side. So I'm just going to move these things that don't have y primes to the other side. So I have 28y cubed y prime plus x cubed y prime, and I'm subtracting these other things. So I'm going to have a negative 3x squared y, and I just like to rearrange it. and a negative 1 when I move them to the other side of the equals mark. Okay, at this point you're like, what do I do? This is why I mentioned GCF. Both of these things have y prime. I mean, granted, sometimes they'll have other things in common, but all you really care about is that y prime. When they both have that y prime, or you have several things that have that y prime, you can factor it out like you would a GCF. And you have 28y cubed plus x cubed left. And then you just divide both sides by that. So your y prime is going to be negative 3x squared y minus 1 over 28y cubed plus x cubed. Okay, so moving on to example 2. This is kind of similar. I have a piece that has regular x, so we treat that normally. A piece that has x and y, which will be a product rule. And the piece that has y to a power, which we will treat as a chain rule. So the first one, 3x squared, is just going to be 6x, because that's just normal. And then I have a product rule. So first, derivative of the second plus the second times the derivative of the first. And then I bring down that negative and I do a chain rule. So 2 times 2 is 4, y to the 1, and then times the derivative of the inside, which will be y prime, and the derivative of 0 is 0. Okay, our second step is to put the y primes together and everything else on the other side. So I'm going to look, this piece here has a y prime and this piece here has a y prime. It's a piece if it's all multiplied. Those pieces get separated by the pluses and minuses. So these two pieces I'm going to keep on the left side. And I'm going to subtract the 6x to the other side and subtract the 1y, so subtract y to the other side. And we're in a situation that's similar to last time. I have y prime in both of these pieces, so I'm going to factor it out. It's going to leave me with x minus 4y. And then I'm going to divide. So y prime is going to be negative 6x minus y over x minus 4y. Okay, example 3, we start to mix in some of our other rules. So when you look at this, this first piece has x's, but I mean it's still a product rule because it's two things that are multiplied. The y cubed, again, we treat like a chain rule, and then this natural log of y will also be a chain rule. So starting with our product rule, first times the derivative of the second plus the second times the derivative of the first takes care of the first piece. Bring down the plus. The y cubed, again, is a chain rule, so 3y squared times the derivative of the inside, which will be y prime. And then finally, I have natural log of y, so that rule is 1 over y, but I have to treat it like a chain rule because I don't know what y stands for, so I multiply by y prime. Now, when you look at this, you have two pieces with y prime. You have this piece and this piece, and I need to get those together. And before, I have gone to the left, which I can do. It'll just take a little bit more work, but it's going to be actually easier in this case if I take that stuff to the right, which is fine, because all the other is still together. So, in other words, on this side, I'm going to have 1 over y, y prime, minus 3y squared, y prime. Now, on this side, I am going to simplify a little bit. X times 1 over x, those cancel, and I just have 1. And then natural log of x times 1 is just natural log of x. So I am going to simplify a little bit right there. But the steps from there on are really similar. I'm going to factor out a y prime and have 1 over y minus 3y squared. And then I'm going to divide by that piece. So I have 1 plus the natural log of x over 1 over y minus 3y squared, and that one solves for that derivative. Alright, example 4, we bring some trig into it. So again, when I look at this, I treat x as normally, so this whole right side is going to be kind of normal. This left side is obviously going to be a chain rule with a product rule inside of it. Okay, and we're treating the y like it stands for some sort of explicit function. So I'm going to do the derivative of the outside. Derivative of sine is cosine. Then I'm going to multiply by the derivative of the inside, which is a product rule. So first, derivative of the second plus second derivative of the first. Then I go to the other side. The derivative of 3x minus 4 is just 3, because all that side is normal. Now, what to do from here is kind of may feel odd to you. Normally you would want to distribute something that looked like this, but we really don't, because we only have one piece with y prime in it. This piece that I would be distributing doesn't have y prime, so I'm actually going to go ahead and divide by that because it is multiplied by this other piece. So I'm going to divide by the cosine x squared y piece and cancel it from that side, and that would leave me with the x squared y prime plus 2xy. I also want you to look at what happens over here. I have 3 over this, which, you know, I can leave as a fraction and that's fine. But we also know trig identities, which can make this not be a fraction, make it not be so ugly. I can turn that into 3 secant x squared y and not have to deal with a fraction right now. Then, again, the goal is to get the y prime by itself, so I want to subtract the 2xy. So x squared y prime equals the 3 secant x squared y minus the 2xy. And then finally, I want to divide by that x squared. So it's the whole side over here. Divided by x squared. Okay, again, we want to mix in a few more rules right here. So I'm using e to the x in this one. We have a product rule on the left side and a product rule with a chain rule on the right side. So I'm going to start over here with my product rule. I have first the derivative of sine y, derivative of sine is cosine, but I also have to do a chain with that because of the y. So first derivative of the second plus the second derivative of the first. And that takes care of my left side. My right side again is a product rule, and I know I'm going to have a chain rule inside of that. So first derivative of the second, so the derivative of e to the cosine y will be e to the cosine y. Then times the derivative of the exponent, derivative of cosine is negative sine, and the derivative of y is y prime. So that was first derivative of the second plus the second times the derivative of the first. In that case, it's just 1 because derivative of x is 1. Now this looks really nasty, but again, focus on the pieces that have y prime. So this first piece, everything's multiplied, it has a y prime. And then over here where everything is multiplied, it's a lot, but it's one piece because it's all multiplied. It has y prime. These other pieces do not. So I want to get those together, and I want to get these pieces with y primes together. And since there's one on each side, I can go either way. I'm going to go to the left. So I'm going to keep this as e to the x cosine y, y prime. I'm going to subtract, actually add, because this was negative. Because this whole piece has that negative sign in there, so that whole side will be negative. I'm going to add that and say I have x e to the cosine y sine y y prime. And then I want to make sure that I get the piece that I did not highlight to the right side by subtracting, so minus e to the x sine y, and I already had on that side an e to the cosine y. So that one was a little nasty, but I do have my y primes on one side and everything else on the other, and somewhere I lost that e. Okay. Alright, so the parts that have the y prime, you want to factor that out. And I have e to the x cosine y plus x e to the cosine y sine y left. And then again, this whole side over here stays the same. And there's a lot to it, but again, the steps are always the same, so all I have left to do is divide. And yes, it's ugly, but it's really not that bad to do if you just pick out your y primes. So again, this side over here divided by what was in parentheses. Okay, so this is our last basic example, number 6, x cubed plus y cubed equals 1. I want you to pause and do this one on your own. Okay, so hopefully you did the x regular, just power rule, and then treated the y like a chain rule, so you got 3y squared y prime, and then the derivative of 1 is 0. So this one wasn't that bad. Once you got the y prime solved for, you could actually reduce in this case, which we haven't been able to do in the other problems so far. But we can reduce the 3's here to 1's and end up with y prime equals negative x squared y squared. So since this was so easy, I want to take the opportunity to show you the second derivative of this one. And so you would be taking the derivative of what you just found. So the derivative of the derivative, the second derivative, would be a quotient rule. So we would have the bottom times the derivative of the top, which would be negative 2x, minus the top, and I'm going to put that in parentheses, times the derivative of the bottom, which again is a chain rule, all over the bottom squared. Now, if I'm going to simplify something like this, first of all, I'm going to work with my positives and negatives and fix those. So I'm going to move that negative here to the front and look at this as if it was 2xy squared. The second part, I have two negatives, which would make a positive, and then again I'm going to pull that 2 to the front just because we normally write the numbers, then the x's, then the y's. And then the bottom, we would have y to the 4th when we simplified. So when you get to this point, if this were a multiple choice question where they gave you the original function and asked you to find the second derivative, you're probably not going to find this as an answer choice because this y prime. This would be a place where they would take the y prime that you found and plug it in before simplifying. So you would be looking at what we just did, except where the y prime is, they would put the negative x squared over y squared. And they would probably simplify from there, which the y would cancel one of those y's, and the negative would move to the front. So instead of a plus here, I'm going to put a minus. And then x squared times x squared is x to the 4th. And then I have that y to the negative 1. So this would simplify down a little bit to something that doesn't have y prime in it. Okay, so our last little bit is applying this now. 7 is an example. They want us to find the slope of the tangent line to this at the point 3,1. And so anytime they ask us to find the slope of a tangent line, we're just taking the derivative and plugging in. It's just now, instead of just plugging in an x value, we're going to be plugging in an x and a y. So I'm going to start by taking this derivative, which will be a chain rule. I'm going to have 6x squared plus y squared to the first. And then the derivative of x squared plus y squared will be 2x plus 2y y prime. On the other side, it's a product rule. I'm going to treat 100x like it's one piece and y like it's another. So I have first derivative of the second plus the second times the derivative of the first. Then this one is a little more complicated to get the y primes together. Before, when I had something to distribute, I didn't because I only had the one y prime. Now I have the two y primes. This takes a little more algebra. I'm going to distribute this 6x squared y squared into both pieces. So again, I'm taking that 6x squared plus y squared to both pieces. This is what I end up with. And then I'm still trying to get my parts with y prime together. So identifying those would be this one and this one. I'm going to get them on the left side. So I move both of those pieces to the left side by subtracting that 100. And then I move the two pieces without the y prime that I had not highlighted to the right side. Again, I just had to subtract that first piece. And then I'm to the point where I factor out the y prime. So I just factored that out, and then I have to divide by what's left. So my y prime will be this whole right side divided by what was in parentheses. So I end up with this, and yes, that does look a little complicated, and you could distribute the 12x through or the 12 through, but that's pretty much where you end up. The last thing that we need to do is to actually find that slope by plugging in the 0.31. So everywhere I have an x, I'm going to plug in the 3. Everywhere I have a y, I'm going to plug in the 1. So y prime of the 0.31 is 100 times the y minus 12 times 3, 3 squared plus 1 squared, over, and on the bottom I have 12, the x is 3, so 3 squared plus 1 squared minus 100 times 3. And once you get that all simplified down, you get 13 over 9. And so this would be the slope of the tangent line at that point 3,1. So it's the same exact process, except now we have x and y, so you plug in for both. Okay, and so again, another way that we use this is with tangent lines, and just like before, we need a point and we need a slope. And in both of these cases, I gave you the point. We get the slope from the derivative plugging in. So taking the derivative and plugging in. So I'm going to find the derivative of this, which would be 2x plus 8y y prime equals 0. Subtract my 2x. Divide by 8y. And this is another one that we can reduce to negative x over 4y. Our slope is going to be the derivative at that point, square root 2, negative square root 2 over 2. So negative x over 4y. When we simplify that, that actually comes out to be 1/2. So it's not as bad as you think. So I'm going to take that 1/2 and the point they gave us and write my tangent line. So I need to be in point slope form. My slope goes in front. I have y minus the y value, x minus the x value, and again, for the AP exam, you do not have to simplify. You can leave it in point slope form if you want to. Okay, for our last example, we're doing the same process. This is one that I would actually distribute before I started taking the derivative just to make it a little easier, because that would become x to the 4th plus x squared y squared equals y squared. And that's going to be a little easier than doing a product rule here. So my derivative would be 4x cubed plus first times the derivative of the second plus the second times the derivative of the first, and then on the other side you have a chain rule, 2y y prime. And again, I want to get those y primes together and solve, and we've done a lot of that, so I'll go ahead and tell you that that ends up to be negative 2x cubed minus xy squared over x squared y minus y. And so this may be a place you want to pause and see if you can get from this step to this step. when you plug in the point that they gave you, again, you're plugging in this point to your derivative that you just found. So negative 2 times square root 2 over 2 cubed minus square root 2 over 2 times square root 2 over 2 squared. And again on the bottom, square root 2 over 2 squared times square root 2 over 2 minus square root 2 over 2. All that takes a little bit of work, but it's going to come out to be 3. And I'm out of room, so I'm going to write it up here. We have a slope of 3, and this point that they gave us. So point slope form says y minus my y value equals my slope x minus my x value. And again, getting there we've done a lot of, so make sure you can get from that derivative to that y prime solved, and then make sure when you plug in you can get to a 3 to get that slope. That concludes this lesson.